Hello everybody, we're getting close to be able to construct our own machine learning model, which we will do in a few videos. The last video we started looking at this example of tuples of data with the number of inhabitants being the x-coordinate and as y, the average income of the inhabitants of such a city. And recall that the goal, the idea of this supervised machine learning was looking for this function f that for all of our n data points is very close to the actual value if we evaluate f in its x coordinates. Now we saw in our training data, if we plotted it, then we also say that we make a scatter plot of our data, that this looks like a linear connection. So we were looking at the family of functions of polynomials of degree at most 1, which I can consider as a function from r squared times r to r, which maps this guy to mx plus q. Now suppose that somehow we have m and q fixed, then what we can do is we can evaluate f, m, q, and xy. We know that this equals mxy plus q. And we need to compare this with the actual value of the y coordinate of that ith data point, so we can actually compare this. So how you can do this is you can subtract yi and take the absolute value of this thing, and we're going to do this for each of our n data points. And what I actually calculated here is what I can say this is the loss of my function. Why do we call this loss? Because this is saying how much we are deviating from the actual target values here. And again, we speak about loss of functions because again, we can actually consider this as a function. Function L from r to the power 3, r cubed to r, which maps, or this is rather from r squared, because we're working with polynomials of degree at most 1. So there are just two weights of our functions m and q, which maps this tuple m and q to exactly the loss here. I is 1 to n, absolute value of the difference mxi plus q minus y. So that's my loss function. And now what to do is, okay, the question we can ask ourselves now is how can we minimize this loss function. And for that we're gonna use what we have learned about partial derivatives.